So we're going to look at the start of our Chapter 6 notes here on the mole. So the mole is a standard international unit for the amount of something, okay? And it actually equals a specific number of particles. And the definition, the formal definition of a mole is the number of particles in 12 grams of carbon-12. And remember, when there is a number after the name of an element, it is an isotope, and that is telling us the mass. Okay, so it has a mass of 12 AMU. Now, why do we use the term mole instead of just counting individual atoms? Well, there are a ton of atoms in everything, a ton. And so it's a lot easier to group into a larger scale, such as the mole, instead of individually counting, because we would be at a really large number. Now, I want you to kind of think of the term mole similar to a dozen. We say there are 12 dozen eggs. Instead of saying that there are 144 eggs, it's easier to reference a dozen than it is to reference the individual eggs, and that is similar to the mole. It's easier to reference the mole than it is to reference the number of atoms in a mole. Now, we said that it equals a specific number of particles. Now, other words that we used for particles include atom, molecule, or formula unit. Skip this fourth one here. I added an extra area that I did not need. Now, how many particles are in a mole? And remember, again, that particles word can be replaced by any of these three. And the answer to that is 6.02 times 10 to the 23rd. And we call this Avogadro's number. Amadeo Avogadro is the man that discovered this number, which is why it is named after him. Now, how do we express this as a conversion factor? Because that is how we're going to use it in terms of chemistry. It is 1 mole is equal to 6.02 times 10 to the 23rd. And again, we can put particles, or we can put atoms, or molecules, or formula units. And here are two ways that we can use it when we use it in terms of dimensional analysis. So let's go ahead and apply this concept. How many moles of xenon atoms are in 5.66 times 10 to the 23rd atoms? So I always like to circle what I'm trying to find. And I'm going to start with what I'm always given, 5.66 times 10 to the 23rd atoms, xenon. And again, we always draw our dimensional analysis. If it helps you to remember this is on the top, you can put a 1 underneath. We're then going to put the unit that we are given, that we are starting with, we put on the bottom. The unit we are going to goes on the top. In this case, it is moles. All right, now we need to put our numbers in. 1 goes with the word mole, moles on the top. 6.02 times 10 to the 23rd goes on the bottom. Now when we have 1 on the top, 1 on the bottom, we go ahead and divide. So I'm going to go ahead and show you how to do that. If you have a similar calculator to mine, we're going to use our E key. So to do that, we hit the second button, and then we find this double capital E, and that replaces the times 10 to the. And then we're going to divide 6.02, E23, and our answer ends up being 3 sig figs, so 0.940. And then my units are always what I end with here on the top, moles, and then you want to put an identifier. Let's try one more here. How many molecules are there in 0.187 moles? So we're trying to find molecules. I'm going to go ahead and move this up a little bit. So we're going to start with what we're given, 0.187 moles of H2O. I can then go ahead and take my unit and put it on the bottom. The unit I'm going to goes on the top. The 1 goes with the mole, and the 6.02 goes with the particle, the atom, or the formula unit. Now, since these are both on the top, we're going to be multiplying them. So please excuse the lights going out here. 7 times 6.02, second E23. And my answer ends up being 1.13, 3 sig figs here, times 10 to the 23rd, and I end with the unit that is on the top. In this case, it is molecules. And that's how you convert between moles and molecules.